Recording. Okay, so it says let f be a function having derivatives of first orders of all orders of the real functions to selected values. The first four derivatives shown, f of x at 1 is this, f of x taking all those values. Write a second polynomial f about x equals 0. Use it approximates 0.2. All right, so the way we'd approach that is we'd say a Taylor polynomial looks like the first term. It's f of 0 plus f prime at 0 times x plus f double prime at 0 x squared over 2 factorial. So it says second degree, that's where I'm going to stop my fun. F of 0 was 4 plus 5 times x plus the second derivative is negative 1 over 2 x squared. They would like me to use it to approximate, to do f of x over here is approximately equal to, all right, and then it says write a secondary approximate that. So f of 0.2, so I'm going to plug a 0.2 in everywhere, and I get 4 plus 5 times 0.2 equals blah, 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 1. Minus 1/2 times 0.2 squared, which is going to be something 0.04, 0.02, so this becomes 4.98, I think. Doing some quick math in my head. And getting part B, it says, let g be a function such that g of x is equal to f of x to the third. Write a fifth degree Taylor polynomial for this g prime of x, derivative around g about x equals 0. So, fifth degree polynomial to take a derivative. Okay, so f, oh, I need a pen, would be good. F of x, sorry, g of x equals f of x to the third, which would be everywhere I have an x, I replace it with an x to the third. So this is going to be interesting. So I'm going to get 4 plus 5x to the third minus 1/2 x to the, what would this be? This would be x to the 6th. So they want a fifth degree polynomial. I'm about to take a derivative, so I'm not going to worry about the rest of this because it's not going to be relevant. Take the derivative, so g prime of x would be equal to 15x squared minus 3x to the 5th. I hope that's the right answer. And then I'm going to clear my board. So I'm going to clear my board. All right. So next on our list is, now we're going to use the one column. It says write a third degree polynomial for this. So I'm going to go ahead and say, oh, well, that's just f of x is equal to approximately f of 1 plus f prime of 1 at x minus 1 plus f prime at 1 double prime at 1 x minus 1 squared over 2 factorial plus dot dot dot. And so my function is going to be equal to f of 1, which is 8 plus 3 times x minus 1 plus negative 2 times x minus 1 squared over 2 factorial plus negative 3 halves, positive 3 halves, x minus 1 to the third is my third degree polynomial. Hopefully I did that right. 8, 3, negative 2, 3 halves. Oh, I found my factorial. Ooh, forgot my factorial. Got head faked by my factorial. There's my factorial. All right, we're good there now. All right, so I'm going to make an error bound. So theoretically, I'd use this to find some answer for x equals 1.1. They want to know how big an error is there. So again, loosely described, we're going to say something along the lines of some bad notation issues here. But the error, oops, the error has to be less than or equal to f of z max, for in this case the fourth derivative, right, times x minus 1 to the fourth power all over 4 factorial. All right, and so now we say, well, the maximum the error could be according to that is 300, so I'm going to put a 300 right there. I'm going to note this is 1.1 minus 1 to the fourth power, which is just 0.1 to the fourth power. This is 4 times 3 times 2 times 1, and so 3's cancel out, make this 100. So I end up with 100 times 0.1 to the fourth power, which is going to get rid of a whole bunch of that 100 right there, all over 8. And so with a little bit more work, 2 of these would cancel out one of those hundreds. A tenth of 100 is 10. A tenth of a tenth is 1. So this is to be 1/100th over 8. And so I end up with 1 over 800 has to be greater than or equal to the error in this problem. Okay. I'm going to cheat now. I'm going to look for the notation, because I don't like the notation I used in this. Oh, actually, no, yeah, the notation there does not make me happy, because I used to having, some way to write what the error is. So let me go steal it from the actual key and then explain what they did. All right, I just looked at the key and did the exact same thing I did, so ta-da, we're done. All right, so there you are. Okay, that's how to do these problems. Hopefully you got any questions, post them, please. Have that. Yeah.